I'm Mukta Ashok and I'll be your moderator for today's webinar. Now, as we begin, I want to take you through a few indicators so that we can interact better during the webinar. You're looking at the attendee interface of GoToWebinar. As you can see, there is a viewer window on the left, and this window will show you everything that we'll be sharing from our screen. You also have access to a control panel, which is on the right-hand side, and you can type in your queries and share your comments. So once your questions are being sent, we'll review them and we'll take them up towards the end during the question and the answer session. Also, the webinar is being recorded and everyone will receive a link with an email with a link to view the recording of today's event. Moving on. So to begin with, I'd like to introduce you to our company, Suyati Technologies. Suyati provides marketing technology and integration services for companies that wish to combine the best of breed solutions so as to create a unified approach to customer acquisition. Now, we enable system integration between various CMS and CRM platform and a slew of e-commerce, marketing automation, social media listening, email and social marketing, and customer service systems. Suyati's custom technology solutions have been developed in the companies in the US, Western Europe, and Australia, and have helped many enterprises leverage the web, cloud, mobile technologies to acquire customers through integrated digital marketing. We have a strategic partnership with various technological giants such as Salesforce, Symphony, and MongoDB. We are also a Microsoft certified gold partner. Now, when it comes to Salesforce, we are an app exchange partner and we offer topmost solutions in customization, development, migration, and integration. We have a team of 30 plus developers, which includes their 401 certified developers. And we have created around 1 million LOC delivering out-of-the-box solution, which end up as industry benchmarks. Now, I'd like to introduce you to our featured speaker, Abhishek Shivasubramaniam. He's currently working as Associate Technical Lead at Suyati Technologies. He has been with Suyati for 5 years and is heading the Salesforce Cloud Computing team here. Abhishek's specialty includes C#, .NET, ASP.NET, HTML, Java, JavaScript, C, plus Windows, web services, Salesforce, Apex, and the list just goes on. He's participated in Salesforce yearly marquee event Dreamforce in 2014 and has presented a session on OpenID Connect and single sign-on for beginners. Social media tags, you can use the hashtags and handles to post questions, follow us, or even tag us. So that's all from my end, passing it over to Abhishek.
Thank you, Mukta. All right, so let's move into the agenda of the session. First of all, we'll talk about some basic problems around Apex triggers and some of the most common issues that developers encounter while scaling Apex triggers. Slowly, we will move into the features called as Apex schedulers and batch Apex, which most of you would have been very familiar with in Salesforce. And moving on, we will introduce the scheduler dispatcher framework, and we'll take you through how all those coding and how this framework is implemented in a Salesforce org. And finally, we'll just summarize the takeaway notes on scalability and maintainability. Finally, the Q&A. All right. So problems in scaling Apex triggers. I hope most of you would know what a trigger is. This trigger keyword, this terminology comes from the database world. So an Apex trigger is something that runs on a DML action. Like when you insert a particular record, an update a record, or delete a particular record in Salesforce, usually an Apex trigger is what that gets invoked. Mostly when we add new requirements, when we add new logic and make adjustments to existing requirements, usually developers would look into Apex trigger as one of the most important point where they can start building up their logic. So that is the point to hook your logic. Now, some of the common problems that we as developers would have usually encountered is like the more and more logic we hook into the trigger, the more loaded the trigger becomes. So one trigger is actually considered as one transaction. So one transaction has one set of governor limits. So every logic that runs in that particular Apex trigger has to obey the governor limit that has been assigned when the Apex trigger started its execution. So as and when more logic gets hooked into the trigger, the governor limits get eaten up fast. And also the problem intensifies when the order of execution of triggers on the same object is out of scope. For example, like developers would be designing like after update triggers on the opportunity object. There will be multiple triggers to start off with. But when it comes to Salesforce platform execution, there is no real control of which trigger will execute first. So again, you do not know what is going to eat up your governor limits really fast, right? So it becomes a very major headache when it comes to debugging and finding out a problem or what specific piece in that whole business logic is stopping us from scaling. So now it is high time that we look into concepts like schedulers or batch effects in Salesforce, which give us more room to run the logic. That is, they give us more governor limits. So it's not like you have to shrink or you have to limit. Like for example, SOQL queries, you have to keep limiting. You have to put limit numbers on top of every SOQL query, fearing that the governor limit will fail. You have to keep checking governor limits at each point of time. So that all those things are pain points. So when we think of concepts like schedulers and batches, what is the first big attraction? The first thing is the first point of attraction is it is asynchronous. Asynchronous. If you have anything around building a logic which has to execute in an asynchronous fashion in Salesforce, Apex schedulers and batch is the choice. The next important point or the next important um, uh, add-on that this two features give us is more governor limits, more space to run, the more room to for our logic to run. Now, when we talk about the governor limits, it's like the platform allows us to queue 5 active batch jobs in the platform. So 5 concurrent batches can run at a particular time. If you want to schedule more amount of batches, there is a concept called as Apex Flex Queue that was introduced in Spring 15 of Salesforce release, which allows us to queue more number of batches. So it's not like when you queue the 6th batch job, the whole thing starts breaking. You can queue more number of batches till 100 jobs that you can queue in an Apex Flex queue. The next biggest advantage from a governor limit standpoint that you get is 50 query cursors open at a time. So it is like if you are familiar with how a batch Apex is coded, we first of all create a query string, a SOQL command in a string format, and we give it to database.getQueryLocator method. And when that particular statement executes, a pointer is created on the Salesforce platform memory to hold where the records or the results of that particular query are located. So that is called a query cursor. So at a time, you have 50 query cursors. That is amazing. And the next biggest thing which I like the most is 50 million records that a query locator can return. Think about a simple SOQL statement on a lead object. If you just execute it, if you have more number of leads, usually the limit of 50,000 will hit when you execute from an Apex trigger or an Apex class. But from a batch, if you move in the route of creating a query and sending it to the database or get query locator, you can retrieve 50 million records. That's staggering, isn't it? Plus, there is also a scope parameter that the database.execute batch statement gives us. The scope parameter by default is set to 200, which means a batch can run with 200 records at a particular time without chunking the batch job into its in a parallelism effect. But if you feel that the batch job will get more records, for example, this batch job is possible to get more, like every run it is possible to get 1 million records every time. So this batch job should chunk itself and parallelize itself in the platform. You can use the scope parameter. The next biggest thing is 10 callouts each. Each means 10 callouts you can do in the start method of a batch, 10 callouts you can do in execute method of a batch, 10 callouts you can do in the finish method of a batch. That's again amazing. The final attraction is you can execute 250,000 number of batch jobs in a per 24 hours. So that is again like amazing. I just love Apex batches and schedulers right now. So coming on to the third point here, so I talked about the scope parameter, which helps us to chunk the processing at the platform level, and also using the concept of Apex batches, more CPU time is allotted for processing in an asynchronous fashion. That is, in the Apex batch perspective, the max CPU time allowed is 60,000 milliseconds for the batch Apex to time out for a particular operation. But if it was in the synchronous fashion, like in an Apex trigger, it would easily time out in 10,000 milliseconds, right? Also, the next important thing is that using Apex schedulers, you can automate the schedulers. You can schedule it automatically, you can abort it automatically, you can reschedule it automatically. So that is again left to the way in which the developers code. So if you code it in a way that all these things can be automated, Apex schedulers are going to be just like in dreamland. Also, the next biggest thing in an Apex batch is that it can persist stateful information. For example, you declare a particular variable at the start of a batch and you want to access the value of it, or you want to update that value of it, and it should be accessible in all the three methods like start, execute, and finish. You can configure the batch Apex class to use the database.stateful to persist the stateful information. Also, you can do callouts, as I mentioned earlier. Uh, One more thing that we have to understand from an Apex batch perspective is that every Apex batch is considered as a separate thread of execution. That is, it is one single independent process that has its own governor limits. The governor timer, it's like when the governor limit timer starts, you can actually basically start a timer at the point when the Apex batch starts, and at the end of the Apex batch, the timer ends. So for every batch execution, it is separate timers. But for if you think from an Apex trigger, the moment it enters the Apex trigger, it is just one timer that starts ticking. And by the end of the Apex trigger, if it's a huge Apex trigger, the time taken would be it would be too much. Now, familiarizing the scheduler dispatcher framework. So I hope you have got an enough idea of what an Apex scheduler and the batch Apex in Salesforce can help us. Now let us see how the framework basically can be visualized. It is very simple that there will be a main Apex scheduler. So you have an Apex scheduler class that automatically schedules at the start. At the top, it will schedule, and when it starts running, it will dispatch each Apex batches as per the criteria that is met. For example, the Apex batch 1 could be executed when it is 9 a.m. on every day. Apex batch 2 could be executed when there are orders landing on the Salesforce to execute a particular logic for maybe like updating associated opportunities or something like that. So independent logic can be executed at various criteria based on this Apex scheduler. So this Apex scheduler, simply what it does, it simply dispatches the Apex batch, and it will reschedule itself. And also, the next big thing, if you look at the third Apex batch, I have put a cross mark on top of it. What it means is that if you want to maintain a particular logic that is written like a Apex batch 3, you can easily detach that batch out of the framework or out of the dispatcher framework. You can do the necessary refactoring, the code refactoring. You can write the unit test. You can make sure that the Apex batch is robust enough to get attached back. Then you can attach it back. So this kind of attaching and detaching functionality is provided by this scheduler dispatcher framework. Let's go into the demo and see how this framework has to be designed. So first of all, we need to understand how the Apex scheduler or the main Apex scheduler should look like. So as you can see, this class implements the schedulable interface. So if any class implements a schedulable interface, it is considered as an Apex scheduler. Now what I do in the execute method of this Apex scheduler is that I look at a table called as schedule job. Can you see this? Select name job class from schedule job. So what is the schedule job? Let us go back into the org and see what it is. This is nothing but a custom object that I have created to hold individual job information like batch 1, batch 2, batch 3, batch n, all these things, when it has to start, when it has to end, what is the next schedule time, what is the interval, is it active, is it not active, what is the job class responsible for running this particular job, what is the status of this job, is it in holding state, is it in queued state, is it failed, completed. All those information can be kept in this particular table. The beauty of this table is that I can easily, if I want to reactivate this particular job, I just need to go ahead here and untick this is active and my job will not run. So you need not stop any logic or any major logic in your Salesforce platforms. You can keep your business running 24 hours without being stopped. Going back to the code, what I do is I go into that particular table and I will query all the jobs that are that can be run at that particular interval of time. The next thing that if the if statements that you see here are basically logging frameworks. Now, one most important thing that you need to think about is that when you implement the scheduler dispatcher framework, this is something which is going to run 24/7, right? The Yeah, so this framework is going to run 24/7. So you need to make sure that any exceptions or any errors that are encountered in the system gets logged into a custom object. Maybe you can call it as a debug log or something like that. So I have designed another table called as debug logs, which will basically record from which class, which method, what error, is it an error or an information, all those information will be logged here so that I can use this for debugging the framework in case there are any errors. Okay, now moving on to this for loop, what I will do is for every job that is shortlisted to be run at that particular time interval will be sent to a can execute job. Now what does this can execute job do? It checks, is the environment in the Salesforce perfect for me to run this bad job? Is the bad job already running at this particular time? If it is already running, I should not be executing this bad job again, right? Now, is the Apex Flux queue full at this point? So I do not have room for me to submit a bad job. So all those checks are done inside the can execute job. So that is what I have basically written out here. I'm basically looking at the async Apex job um, to see if I have room to submit my batch jobs. So if that method returns true, I will go ahead and execute that batch. Now, which class I need to execute? That comes from the schedule jobs job class field, which is nothing but this one. You can see here the job class is bad job one. So bad job one is the class name, right? Also, if the environment is not perfect at this particular stage, that means it will come to the if else part. So if it comes to the else part, I'm just going to log it in my debug log so that I can make sure that all these kind of scenarios, corner cases are captured in my system, right? Finally, what we will do is to reschedule the dispatcher so that it will again start listening for the jobs on the next interval, right? Now, what does the reschedule the dispatcher code look like? It does nothing but create a cron expression that we obviously do while scheduling an Apex scheduler and send it to the system.schedule command. That's it. So as you can see, the dispatcher just contains logic about filtering out the jobs that has to be run at that particular time, execute it if the environment is perfect at that particular time. If it is not perfect, log the error and reschedule the dispatcher. There is no business logic in this dispatcher. Dispatcher is simply something like an something that can run 24/7. Now coming on to the individual batch, that is the Apex batch 1. This is also very similar to an Apex batch class. So you can see that it implements the database.batchable. And what I do in this constructor is to create a query. So this is what I need to look at. So are there any records for me to process with this batch job? So if that particular query is formatted in this string, and you need to provide this query into the database.getQueryLocator. So getQueryLocator. So if there are 50 million records also, it will easily fetch and give it to us, right? And all those S objects will come and land at the scope here, the list of S objects here, and you can do the logic. Now, let me now explain the use case that I have basically written out here. So think of an Apex trigger called as lead address verification. So whenever there is an update on the address field on a particular lead, I need to verify this address is correct or not. So that is what my trigger is basically going to work. Assume that the verification process takes a lot of time, maybe it involves a lot of SOQL statements. So we are thinking about a scalable framework at this point. Okay, so you can see the trigger. What it does is it checks if the city has changed, the street has changed, the state, country, postal code has changed. If all those things has changed, what I'm going to do is the code will be like this: address verification manager dot submit verification request sync. That is, in a synchronous fashion, this trigger is going to execute. So it calls another class that is going to execute the second method, that is process, or get all the leads that for which the address has to be verified, and do the address verification logic and set the address verified checkbox on the lead as true. So this is a custom field that I have created. So just mark it as true and update the leads. Okay, so this is taking a lot of time. So how will we now transfer all these things to the dispatcher framework is now the question, right? What we need to do is we need to design another custom object which acts like a queue, a custom object which can catch all the requests for the dispatcher or the individual batches to process. So for this purpose, we have designed another custom object called as async request. Now, what this async request looks like is, for example, it nothing but it basically has a name and it has an async type. Async type is something like a keyword with which a batch job can understand that, okay, this request is for lead address verification. The params are going to be the maybe like the lead IDs that needs to be processed for the address verification. So let me just run this on the synchronous fashion and show you. So what I'm going to basically do is comment out this delete so that you can see how the processes are going to land there. So I'm saving the trigger to go in the async route. So basically this async method, what it does is it is going to insert records into the async request table, right? So we'll see how that records look like. Okay, so I'm going into the leads here. So you can see here that I have a lot of leads, and I'm going to select all these things, make the address verified as unchecked, and I'm going to set this to I'm going to basically change the city so that the address changes here. Now let's see if the async request was populated. Yes. Now you can see that there are a lot of asynchronous requests that has been populated in this custom object, saying that a request AR0071 has landed for lead address verification on this parameter. That is, this ID is the lead ID, right? Now what my dispatcher is going to do is the dispatcher is going to sit and run. You can see here that I have started the dispatcher, and it is simply scheduling itself. It is running all the batches, and it is aborting and rescheduling itself, right? Now let's see what happens here. We just need to wait for this schedule job, I mean the Apex batch 1, batch job 1 to complete. So once it completes, it'll just come and update the address verified out here. So I'm just waiting for that to run. So the next time is 7:56. So I'm just going to wait here. Okay. So basically what I've done here is the batch job has been scheduled here to run at every 5 minutes. So this batch job only has to run every 5 minutes. If I want to change the interval of this batch job run, I can easily go here and edit it. Instead of 5, maybe I can make it as 1. So it will execute in every 1 minute. Also, the batch job dispatcher, if you see here at this point, yes. So the batch job dispatcher also has to schedule, it has to abort, and it has to reschedule, right? So common doubt that would be coming in our mind is at what interval should it schedule? What interval should it reschedule, abort and reschedule? That is taken from a custom setting here, and we have called this custom setting as environment settings. So I'll quickly show you how that custom setting looks like. It is under the develop, custom settings, and environment settings, manage. So you can see that the dispatcher interval is set to 10 seconds. So the main dispatcher will schedule itself in every 10 seconds. It will schedule, abort and reschedule itself in every 10 seconds. So in that 10 seconds when it runs, it will check if any jobs in this particular scheduled jobs are eligible to run at that particular time. Has it reached the 5-minute mark? If it has not reached, it will skip and reschedule itself. If that 5-minute mark has reached, then it will basically dispatch this job and it will run it. Now I hope this should have run. Let us see. So I'm just waiting for it to run. As soon as it runs, the leads address verified should be checked out here. All the async requests should be flushed out. And the scheduler should reschedule itself. Right. So I think we'll wait for that. Maybe we'll just move into the next section of the takeaway node. So basically what we learn from this scheduler dispatcher is that it is very easy to plug in and detach the batch jobs. The main dispatcher execution interval can also be adjusted easily without stopping it. As I showed you, we are managing it using a custom setting. So anytime you want to increase or decrease the rate in which the dispatcher schedules and reschedules itself, you need not stop the scheduler, but you can simply go and edit the value in the custom setting. So it's something like managing things from a config file, right? So that's really going to be very useful when you take these things into the production system. And also more batch jobs can be designed as per the requirement and attached to the dispatcher. So here in this demo, I just showed you one batch. So that was one record in the schedule job table. So if I have more jobs, like for example, update my when a contact owner is updated, maybe like propagate some changes to the associated opportunities or tasks. If you want to do that, you can design another batch job in the similar fashion that we designed the batch job one, and you can attach. And the moment you add that as a record in the schedule job table and make it as isActive equal to true, the dispatcher will immediately pick it up and start keep it running. Also, if a batch job needs to be edited, for example, if you want to refactor or do some kind of maintenance on top of batch job, it can also be detached. So that is the attaching and detaching is actually the beautiful part of this scheduler dispatcher framework. So this attaching and detaching is the key that helps us to drive more scalability and more maintainability in the platform. Uh, Finally, moving into the Q&A.
So we're ready to address your questions. You can type in your question using the question feature on GoToWebinar. So we have our first question for the day. Should we abandon triggers and move this to dispatcher?
Right. So basically, we should not be doing that kind of thing. Like this is not a total replacement towards Apex triggers. Like this is a point when basically like you overload. You have written too much of logic. You have hooked up a lot of logic on the Apex trigger, and the trigger is eating up the governor limits a lot. So it is you start thinking about moving some parts of it or time consuming or the logic that is doing more SOCL or more processing, that can be moved into the scheduler dispatcher. So it is not, this framework is not actually for you to totally abandon Apex triggers. This is for you to scale things if Apex triggers come to a saturation point. Right. How now we have another question. So how is the trigger logic going to use this framework? So basically, again, as I told you, every DML statement, the entry point is always a trigger, right? So instead of calling a synchronous method, which is time consuming, what we can do at this point is to edit that Apex trigger code, and you can create async request records. For example, maybe I just show you quickly here. For example, what we have done in this trigger is that initially it was like this. Initially it was like address verification manager dot submit verification request sync, right? So sync was actually time consuming, so we wanted to move into a dispatcher framework. So what I did is I just commented this code and I wrote an async method in this same this address verification manager class. What basically it does is it takes all these IDs to process and it creates async request records, right? Any record, all those records will come and land in this queue. So the batch is actually going to read the queue and going to process. Okay. So instead of sync, you actually call an async method, and async method will submit records into the queue. So here you can see we are inserting all the async request and ending it. The trigger is lightweight right now. it just has to insert the async request and it has to exit out. Now what will the dispatcher do? Dispatcher will run there every 10 seconds, and if it is a 5-minute mark, it will execute this batch job. And if you see the batch job code, the query is to look the query the SOQL query is to basically read from the async request where the async type is lead address verification, right? So if you look at this table, I have a lot of records that are of lead address verification. So all these records will be taken into the batch job, and then I will read the params value, which is my lead ID, and I will actually create my lead records and start processing on top of it, right? So you get all the async request out here, and basically whatever lead IDs I got from the params, I'm going to fetch its original lead record, and then I will do the address verification logic. So when you do the address verification logic at this point, now you have more governor limits. You have 50 million record execution limit. You have more CPU, max CPU limit is 60,000 milliseconds at this time. So easily these jobs, these time consuming jobs will run in batch job, right?
So moving on to our next question, what if the main dispatcher stops?
Right. Okay. So that's a very good question. What if the main dispatcher stops? That's going to be a mayhem, actually. So what that this is the main reason why I said that when we design the dispatcher, this has to be exception proof. If there are any exceptions occurring in this dispatcher framework, uh, if we are getting any exceptions in this framework, we should have try catch blocks, we should have information logging, we should have error logging. Any exceptions that occur, it should never break this dispatcher. You have to design this, the way in which you have to write this execute method should be in a way that all the exceptions, errors, debug statements, everything gets logged into your custom debug log, so that you have a very clear idea of how debugging and how maintenance has to be strategized on a later point of time without stopping the dispatcher, right? So that is a very important point. If possible, it is also good. In this example, I have not done that. If possible, in the catch exception, maybe we could log that particular error and try to reschedule the dispatcher once again. If it is an utter failure at that time also, then maybe we could exit. But if we are able to reschedule the dispatcher at that second retry, that's going to save the dispatcher. I mean, save our business basically from stopping, right? So it'll easily restart itself. So you have to design all these things in a way so that it has a self-healing kind of capability in it.
Okay, we have another question here. Just give me a minute. Um, okay, can you please post the link for the code base for this framework and the logger framework as well?
Yes, sure. Soon after the webinar, once the recording comes live, we will surely provide you all the materials along with that.
Okay, next question is, if you want to add some logic to a bad job in this framework, is it simple as editing and saving this class?
Exactly. Because let me show you that piece also. Like if there is a situation where the business comes to us and they say that, hey, we need to add some more web service calls, or maybe like we need to add a little bit more coding on top of it, a little bit more requirements on top of this bad job, which is currently running in production. So what do we need to do right now? So I mean, basically, when you take it from the sandbox, what you will do is you need to go into the scheduled jobs, and I will just pick this record and make it inactive, save it. Now I am damn sure that this bad job will not be picked up by the dispatcher. So now it is free to be edited. Now you can come to your IDE, you can start editing all these things. Maybe I can uncomment this line, then I can start saving it, and soon you will see that the code is able to get edited and saved. If it is already running, what will happen is, if you don't make it as is active equal to false and you try to edit it, maybe that bad job is trying to run and maybe it will conflict. So it is always best to unplug it, detach it from the framework, edit the code, save it, do all the unit tests, make sure that all the scenarios, the positive, negative cases, neutral cases, everything is handled, and then after that you come back into the scheduled job and make this thing as is active equal to true and save it. That's it. It is attached.
Okay, I think that was clear enough. So moving on to our next question, can we adjust dispatcher execution interval?
Dispatcher execution interval, yes. Dispatcher is basically our Apex scheduler. So as I showed you in the code, the dispatcher is governed by the environment settings, custom settings. So basically, it is in the this particular custom setting, that is the environment settings. I have a scheduler dispatcher interval. So this is set to 10. So if you want to instead of 10 seconds, so if you think that okay, none of my bad jobs basically run every 10 seconds, so maybe I can make this dispatcher to run every 1 minute or maybe like 2 minutes. Let us give us it some more time, some more breath to run. So you can come to this custom setting and increase this value to 20 or maybe to 300, whatever it is. The dispatcher will automatically adjust. The same thing you can do on the bad job. The bad job is governed by the interval minutes in this particular record. So if you want to increase this from 5 minutes to 10 minutes, you just go ahead and make this as 10 and save it. Things are going to get adjusted the next time it runs.
Okay, cool. So we have a follow-up question for that. Likewise, can we adjust job run interval?
Yes, that's what I just explained right now. You can come into the schedule jobs custom table and you can change the interval minutes out here. Either if you want to increase, you can increase it. If you want to decrease it, you can also decrease it. But you have to make sure that the dispatcher runs more frequently than the batch job. That's it.
So I think that's So that's all. All the time we had. Please do look up for a follow-up mail that will alert you on to the on-demand status of the webinar, and you can review any material that you had missed, or you can simply go over again. So any further queries will be taken offline. You can reach us at our social media, or you can simply drop us a mail at webinar@suyati.com. So that brings us to the end of our webinar. On behalf of Abhishek and our team at Suyati Technologies, thanking you for joining us and taking time to attend our webinar. Have a great day.